Okay, now let's see how we can actually determine a confidence interval here for our non-diabetic group of people. And as we said in the previous session, we need to have an idea about the variability. We need a sample size and we need the error. The good thing is we can use just simply one sample that we've taken here. Because what we can do is just simply we say, right, there is a good, if we just simply take one sample, it's very unlikely, there's only a 5% chance that we take one of these outsiders that are outside the confidence interval, but it's more likely to pick one of these samples from this 95% confidence interval. Let's say we take this one here, or we might take this one here, and we use that to estimate the confidence interval. And with confidence intervals, it is basically like brushing teeth. You just simply do it. You don't think about it a lot. So whenever you have a sample, you calculate the confidence interval. So what do we need? We need the variability, and we said it's the variability of the population. So we need to estimate the variability of the population. And we do that with the standard deviation of the population. So that would be, when I talk about variability, this is the standard deviation of the population, and we need to estimate that. Estimated, and the only estimate that we have is by looking at the standard deviation of the sample. Estimated by sample standard deviation, and abbreviated as standard dev. So that's a little bit of a tricky part. Sample size, well, that's not too difficult. We can do that immediately. We can put that in here. So the sample size is just simply our count of 9. And the type 1 error, and we just simply go with the standard that we said, usually is set to 5%, which means that only 5% of all the samples that we can take will be outside this confidence interval. And that's a sort of a healthy balance between making the confidence interval too small or too large. So 5% is set very often, and we can do that here already. We set that to 0.05, which is 5%. And now we need to calculate the variability, that's the standard deviation, based on this sample here. So we can do that in Excel, and we put in standard deviation, and we see here the standard deviation S. This means we use the sample to estimate the population. We click on that, drag down, left mouse click, drag down the data, and we get a standard deviation of 0.52. And now we want to calculate the margin. What we do is we calculate what is called a margin of error. So what is a margin of error? Well, what we do is when we have, in this particular case, for this kind of numbers, and I will say something about it, what we say is, well, we have our confidence interval and we have our mean in the middle here, 4.3, and for this particular case the confidence interval is symmetric around the mean. So the whole part here, that will be our confidence interval, and just one arm here, that will be our what is called the margin of error. And for this data type, the margin of error is symmetrical. So if we know the margin of error, we can calculate this confidence interval just simply by either adding the margin of error to the mean or by subtracting the margin of error from the mean. So how do we calculate that? So let's put in a margin of error here. And again, there is an equation in Excel that allows us to do. It starts with the equal sign, and we want a confidence interval. We start typing. Now we have the choice between norm and t, and here, because we don't know anything, we need to go for t, because that follows a t distribution, and I have another video on that. Now it asks us about something that we've already done. So it asks us for the alpha for our type 1 error, so that's this one here, 0.05. It asks us for the standard deviation for the estimate population, because we know that this is the variability of the population. So we click that. And it asks us about the sample size, and we've got that here. That is 9. So we can calculate the margin of error. And I make this a little bit larger here, so that we can see that. So that is our margin of error. That's this part here and this part here. Let's put that to the right number of digits here. So we are going in the wrong direction, we go in the right direction. So that would be here our number of digits. We have only one decimal place. Our margin of error would be 0.4. So what we know is, for our confidence interval, 4.3 is in the middle. So margin of error is 0.4 and 0.4. So therefore, our confidence interval, as judged by this sample here, our confidence interval would go from, let's do the lower one first, 4.3. So that is 4.3, take away 0.4. So that would be 3.9. And here we have 4.3 plus 0.4. So this would be 4.7. So we would report that the confidence interval based on the sample would be 95% confidence interval. This would go from 3.9 to 4.7. And that's a decent way of reporting that. So that means when we look at our confidence interval here, this means for our 95% confidence interval, it is 3.9 to 4.7. And we expect that 95% of all the samples that we would take are in this range, and actually our estimated population mean would be 4.3. So that gives us a good idea which samples actually belong to this non-diabetic population. So we would, if we just simply check, is there anyone, let's say, with if we have a sample with glucose value of 3.2, we find that this 3.2 very clearly is outside. So 3.2 is outside our confidence interval, and therefore we would say most likely not part of this population, not from this population. because this population should really have sample means only in this range. So this confidence interval gives us a good indication whether a sample belongs to this population or not. And that is how we actually calculate this confidence interval. The equation for this margin of error actually looks like this. We need a critical t-value, and we will discuss what this is, times the standard deviation divided by the square root of the sample size. So that here is the standard deviation. Maybe I should do it like that. This is the standard deviation of the population estimated by the sample standard deviation. That is this S here, and this N is the sample size. And this T here is sort of our factor that takes into account the type 1 error and also the sample size to a certain extent. So I hope this makes sense, and thank you very much for watching.